Hi, students, and welcome to today's lesson. I'm Mrs. Quarterman. Today, we will explore the question, how do we describe our view of the sun, the moon, and stars in Earth's sky? Are you ready? Grab your pencil and your science journal, and let's get started.
Let's start today by looking at this photograph. Take a moment to study it closely. What do you notice? This is a photograph of an original artwork. The title is Celestial Navigation. The artwork was made by an artist named Joseph Cornell. It is a box with a glass front, and it contains objects that tell a story. What materials do you notice the artist used to create this artwork? Do you notice the 4 glasses? And that one of them contains blue marbles? And hey, do you see the large ball up here above the glasses? The ball looks like it's resting on metal bars, doesn't it? I wonder if it can roll back and forth. Did you notice his face? I almost missed it at first glance. We have been talking about celestial navigation, or navigation using the sun, the moon, and the stars. How does this piece relate to celestial navigation? I notice that this part behind the glasses looks like water, or maybe some land. Do you think that the top blue area represents the sky? It could. What about the large ball floating above the glasses? Could it be the sun, or maybe the moon? I wonder. Let's focus on the face for a moment. What do you think this person would see? Well, the person would only see what's in front of them, right? So the person would see the glass with the blue marbles or the wall of the box. But the person would have to turn their head to see the large ball or the other 3 glasses. How is what you see in the artwork different from what this person sees? We have a different, more complete view, don't we? We're looking from a different angle, so we can see more of the artwork. The person can't see things behind them like the large sphere, but we can. Compared to the person in the artwork, we as the audience have a different perspective. Perspective is a term used to describe how the appearance of an object changes depending on the viewer's relative distance and position. In this lesson, we'll consider how changing our perspective affects our models of what we observe in the sky. One of your tasks last time was to complete a model of celestial objects from the perspective of ancient Polynesians who used these objects for navigation. Our model should show objects for daytime navigation and nighttime navigation. Which celestial objects did you include on the daytime side? Did you include the sun? How about the nighttime side? Let's include the moon and the stars. Great work! Today we are going to think about these objects from a different perspective. I wonder what perspective astronauts have of celestial objects. Today we are going to read from this book, Look to the Stars, written by astronaut Buzz Aldrin himself. Did you know Buzz Aldrin was the second man to set foot on the moon? Wow. Let's read a few sentences. They were known as the Mercury 7, and they were ready for a bold challenge to break the grip of Earth's gravity and become our first space travel pioneers. Alan Shepard climbed into the tiny, cramped Mercury 3 capsule, Freedom 7. The spacecraft measured just 6 feet 10 inches in length and 6 feet 3 inches in diameter, not much bigger than a go-kart. The capsule is not very big, is it? Alan Shepard became the first American in space, and although he didn't orbit Earth, Shepard reached an altitude of over 116 miles during his 15-minute flight. This is a picture of the rocket that launched the Freedom 7 capsule into space. Do you see the Freedom 7 capsule on the rocket? Imagine you are Alan Shepard taking off and rocketing into space. What would it be like to be one of the first humans to leave Earth? Wow, I think it would be so exciting, don't you? And maybe scary too, with so much unknown to discover. What might Alan Shepard have seen as he left Earth and traveled into space? As he traveled farther away from Earth, do you think he was able to see that the Earth is round? I wonder if he could even see daytime and nighttime. I know, let's draw a model representing what Alan Shepard might have seen from his outer space perspective. What objects do we need to put in our model? Since we said that Alan Shepard might see that Earth is round, I think we should include the Earth. What else should we include? Well, we know that the sun and the moon are celestial objects, so let's add them to the model. What other celestial objects can we see in the sky? Did you say stars? That's a great addition to the model. Let's add a few stars. I think we need a title for our model that describes the system of objects. Let's use the names of the objects we just added: Earth, Sun, Moon, Stars, System. How can we describe what we drew in our model? Well, we are able to see the Sun, the Moon, and stars from Earth because they are in space around Earth. We observe that the Sun is in the same position in the sky at the same time each day. Great work! Drawing this model will be one of your tasks for today. Now we have two models of celestial objects, one from the Earth perspective and one from the space perspective. How do the models compare? How do the components of the system interact? Let's keep thinking about these questions. As you think about the models, what do you already know about the Sun, the Moon, and stars? Maybe you've noticed that sometimes the moon is round, and other times it looks like a sliver of light. Or maybe you know that you can find the North Star because it is very bright, and it is always in the same place in the sky. As you look at the models, what questions do you have? One of your tasks for today will be to write 3 questions you have about the Sun, the Moon, and stars. We will use those questions to help us form our driving question board in the next lesson. Let's review your tasks for today. First, draw and explain the anchor model. Second, record 3 questions you have about the Sun, the Moon, and stars.
Welcome to today's lesson. I'm Mrs. Baidani. Today, we are investigating the question, how do we describe our view of the Sun, the Moon, and stars in Earth's sky? Are you ready? Grab your pencil and your science journal, and let's get started. In our last lesson, we learned that celestial objects can appear very different depending on where we are standing. To help us document these differences, we drew 2 models. How are the models similar? I noticed that both models contain the same objects, the Sun, the Moon, and stars. But the objects don't appear exactly the same in each model, do they? How could the same objects appear different in our 2 models? Did you say that they are drawn from different perspectives? They sure are. What are those perspectives? The first model is drawn from the Earth perspective. We drew the celestial objects from our point of view on Earth looking up at the sky. The second model is from a space perspective. We drew it by predicting how these celestial bodies would appear to an astronaut looking at them from Space Shuttle. When we look at the system from space, we have a broader perspective. We can see more of the system. Compare this with the perspective we enjoyed as viewers of the shadow box work of art. We can see more of the artwork from the outside than the person in the shadow box can see. As I look at these 2 models, I have a lot of questions. Do you? Your task last night was to write 3 questions you have about the Sun, the Moon, and stars. Today, we will use our questions to build a driving question board. Our driving question board will organize our thoughts and help us make more sense of the Earth, Sun, Moon, star system. As you look at our 2 models, what do you wonder? I wonder about the Sun, and I have many questions. How can we use the Sun to navigate? And how far away is the Sun? Do you have other questions about the Sun? Look at this photograph. Have you ever noticed that you can see the Sun in different places in the sky throughout the day? Have you then wondered, is the Sun moving? If you notice the Sun's apparent movement, did you wonder, does the Sun appear to move in the same direction each day? I wonder, what makes it look like the Sun moves through the sky each day? These are all great questions. Wow, let's take all of our questions about the Sun and add them to category 1 of our driving question board. But this category needs a heading. Our heading should be a question that covers all the questions we have. Let's call category 1, how can we explain our observations of the Sun? Great work. Now that we've asked questions about the Sun, do you have questions about the Moon or stars? As I look at our 2 models again, I have some questions about the Moon. Do you? Do you think we can use the Moon for navigation? Let's add the question, how can you use the Moon to navigate? As I compare the models, I wonder, how far is the Moon? Look at the beautiful moon in this photograph. On some nights, we can see the moon clearly, as in this photograph. But on other nights, we can't see the moon at all. And some nights when we see the moon, it's not the same shape as this round moon in the photograph. Why isn't the moon visible every night? And why does the moon's shape change? Do you think maybe the shape looks different some nights because the moon is moving? Does the moon move? Have you ever seen the moon during the day? I have too. In the early morning or the late afternoon, sometimes the sun and the moon are visible at the same time. Why can we sometimes see the moon during the daytime? And hey, do you think our moon is the only moon? Or are there other moons? Let's add all these questions to a new category of our driving question board. All these questions are about the moon. So let's call this category, How can we explain our observations of the moon? Great work. I wonder what other questions we can come up with next. Oh, what about stars? Do you have questions about stars? Are you wondering, what are stars? And how can you use stars to navigate? I wonder, how far away are stars? What else can we ask about stars? Are there patterns in how stars appear from Earth? Sometimes I step outside at night and see different stars. Do stars stay in the same location in the sky every night? How can we tell if stars move across the sky? Have you ever heard of constellations like the Big Dipper? Do you wonder what are constellations? Let's add these questions to the driving question board. Since all of these questions are about stars, let's call our third category, How can we explain our observations of stars? But wait a minute. The sun, the moon, and stars aren't the only celestial objects, are they? Do you have questions about other celestial objects? I'm wondering about other planets. Can we see other planets from Earth? And because we use some celestial objects to navigate, do you wonder, can we use planets to navigate? Have you ever heard of a solar eclipse? Have you ever seen one? Do you know how a solar eclipse happens? Let's add, what is a solar eclipse? I think these are all good questions, but they don't really fit into our first three categories. Let's add them to our driving question board in a fourth category called Other Questions. Do you have other questions to add as well? Part of your task at the end of this lesson will be to sort one of your questions into a driving question board category. Wow, look at all the questions on our driving question board. These questions will help us answer the question, how can we explain our observations of the sun, the moon, and stars from Earth? Before we dive into answering our questions, let's play a game to review everything we've learned so far. I will read several statements. You complete the sentences by filling in the blank. If you think the answer is Earth perspective, touch your knees. If you think the answer is space perspective, reach for the sky. To get started, stand up. Ready? Let's go. From the blank perspective, the sun, the moon, and stars appear to be in different parts of the sky at different times. What do you think? Is it Earth perspective or space perspective? If you are touching your knees, then you are correct. From the Earth perspective, the sun, the moon, and stars appear to be in different parts of the sky at different times. Ready for another one? From the blank perspective, I would see Earth, the sun, the moon, and stars. What do you think? Earth perspective or space perspective? Are you standing tall and reaching for the sky? That's right. From the space perspective, I would see Earth, the sun, the moon, and stars. Great job identifying the differences between the Earth perspective and the space perspective. One of your tasks today will be to describe your view of the sun, the moon, and stars in Earth's sky. In our next lesson, we will continue to look at the sky from different perspectives as we work to answer the question, what separates Earth from outer space? Let's review your tasks for today. First, sort one of your questions into a driving question board category. Second, answer the question about our view of celestial objects.